Last section of chapter 0 is on positive and negative numbers. So, throughout our order of operations, we didn't have any positive and negatives numbers, so you weren't having to worry about adding and subtracting positives and negatives or multiplying and dividing. That's coming up to us in the coming chapter. So this is really, it's definitely simpler than it reads. Math has a good way, or math textbooks, I hope, not me, maybe me, have a good way of complicating things. They're like, why didn't you just say it simply? So positive and negative numbers, we're lucky to live in Canada where we do have positive and negative temperatures. So we do have a good example of that. Positive and negative numbers are both examples of integers. And this is a new bit for us. So we've had lots of kind of vocabulary, product for multiplication, numerator, denominator. Integers is another one. So integers are whole numbers. So integers are natural numbers and whole numbers of their negatives and zero. So all of these numbers on this number line are considered integers. So with that definition, that's from the textbook, we need to classify which of these are integers. Which of these would exist as a number on the number line? So yes, yes. This one, no. What is wrong with that one? It's not a whole number. So even though we would know where that was, it'd be somewhere around here as a value, it's not considered an integer in math. So that's a very specific word. It's not just positive and negative, but it's positive and negative whole numbers, and zero. So, and again, this is a part number, so not an integer. So that'll come back to us in coming sections, and I'll remind you of that. There's a lot of vocabulary, and a lot of it matters. The language of math is very specific, and so that's what we're talking about with integers. These ones, I get a kick out of teaching this every time because it's really pretty straightforward. So if you want to arrange numbers in order from smallest to biggest, that's ascending order, getting bigger, like going up the stairs, or descending. So you ascend the stairs or you descend the stairs. That's why I put those memory devices in there. And I don't know what it is. It's kind of like left and right direction. Sometimes I get things completely backwards, even though I fully know what it is. So writing these in ascending order, we're going to go from smallest to biggest. So the smallest number is -8, -5. I'm sure you're all really glad you're watching this video or in class right now. So that's writing the list of numbers from smallest to biggest, and I think you could do it. Extreme values would be the smallest number, so this would be the minimum, and this would be the maximum. You can go ahead and give the next one a try. Usually people are pretty straightforward with this. What this does build to is what's on the back side of this page, an absolute value. In order to kind of build up to absolute value, we're going to talk about opposite value. So on the number line, 5 would be over here, and the opposite value would be -5. So that would be my answer. The opposite value of -9 is a +9. So we're just flipping the sign on these ones, right? No big deal. But that builds into this idea of absolute value. So just a very short time ago, I talked about the different ways of writing multiplication, and we talked about how there were brackets, and sometimes there were brackets with square brackets around them. All of those are grouping signs. These straight lines here are absolute value signs. They are not like these at all. And that confusion is totally natural because it's all in the same chapter and pretty close together. So what this is saying, and again, like when we were writing out like the division stuff or exponents, the language really matters. Absolute value, it makes the number positive. It's like how many spaces away from the 0 would it be? So we were dealing with 5 and the opposite value of -5. The absolute value of either of these numbers is their distance from the 0. And so the absolute value of 5 is 5. It makes everything positive. The absolute value of 7 is 7. It was positive, it stays positive. The absolute value of -7 is 7. It's still 7 places away from 0, right? -7. Now this one's a little trickier. So this one says we have to read what it means. It says the negative of an absolute value of 7 is -7. So we do this first. The absolute value of 7 is 7, but then we want the negative of it, and that's how we get the answer. So these few examples here are worth going through. Like I said, it's an easy one to kind of gloss over from the textbook, and doesn't, it's not difficult, but it feels kind of tricky because it does seem like the brackets, and it is not. And it's an odd odd thing to put in this review unit. So in class, I know someone will be bold enough to say, when does this ever get used? And so I will answer that in class, or if you're bold enough, ask me in an email. But it has to do with like percentage error sometimes, or change in elevation or depth, or those kinds of things. So yeah, just baiting you to ask me a question here, really. So this one, we're going to work from the inside out. The absolute value, because that's what these signs mean, of -7 would be 7. And then the negative of that absolute value of -7 is -7. Did you follow that? The absolute value of 8 minus 3, well, that would be 5, but we want the absolute value of it, so that would be a positive 5. The absolute value of 8 is 8, and then we're going to minus the absolute value of 3, which is 3, and my answer again is 5. Not hard. In the textbook questions, you'll catch anything. Yeah, this is maybe the trickiest one to watch. Awesome. Well, that is the end of chapter 0. And up from here, we'll move into algebra gently. And you have your homework to hand in. Maybe you've been doing that as you go, and your practice test. Yeah, let me know if you have any questions. Thanks.